Thank you, everyone who stuck around. We'll re-promote this to get some folks back on. I know we lost a few folks during the break, but yeah, this is the last session of the day. So thank you all for sticking around for this. This last one is going to be exciting. I know for all the technical folks out there and all the non-technical folks, we'll try to keep this high level and dive into some details to really understand Move, Rust, and Solidity. Obviously a bit biased here given the conference, but yeah, let's dive into it and get it started with some intros. So I'll pass the mic over to you, Jazzy.
Oh, yeah. Hello, everyone. Thank you for inviting us. And just for my intro, I'm Jazzy. Wait, actually, first, is my mic working fine?
Yeah, I can hear you.
All right, I'm Jazzy, and I'm the co-founder of Zellic. We essentially provide high-quality smart contract audits for Move, Solana, EVM, and even now Cosmos. So, yeah, happy to be here and talk about Move versus Rust versus Solana. Move versus Rust versus EVM.
Awesome, thank you. Over to you, Karthik. Would love to get an intro.
Thanks for having us over here. I am Karthik. I am the CEO and co-founder of Kana Labs. We are basically a DeFi aggregator across multiple chains, including Solana, Aptos, and EVMs as
well. Awesome, thank you. And over to you, Amanda.
All right, thanks everyone. So basically, I'm Mana, co-founder of Hippo Labs. We are building this aggregation mechanism on Aptos, where we basically connect all the liquidity, from all of the dexes on Aptos, including Liquidswap, Pancake, AUX, and a few others, so that our users can always make sure that they trade on Aptos with the best liquidity and with the best rates. So we've been building on Aptos, probably starting last May. So it's been a journey of close to 1 year now, and it's really excited to join this talk here.
Awesome, thank you. And then lastly, over to you. Yeah, I really don't want to mispronounce your name, so please, rep from the Celer Network, please announce yourself and introduce yourself.
Yeah, it's Junda. Yeah, I'm the co-founder and CTO of Celer Network. We started in 2018 as a state channel kind of layer 2 project, and over the years, kind of try to find the market and the technology match. Our most recent or the popular product right now is actually C-Bridge. It's a cross-chain, both the fungible token and NFT bridge solutions. And Aptos, I think we're one of the we're among the first, the big bridges that officially support Aptos network.
Awesome, great. So thank you all for the introductions. Would love to kick it off here, and I think we definitely have a mix of technical and non-technical folks. So would love to maybe kick it off with an explain like I'm five for Move versus Solidity versus Rust. Keep in mind I'm a non-technical person, so how can I best understand these languages and the differences between them? Maybe start off with, we'll start backwards. So maybe Junda.
Sure. Yeah, it's like because it's a mix of both technical and non-technical. For the people, for the technical, I will start with the technical perspective. The programming language, just like any, if you even not looking at smart contract, it's just looking in general, like JavaScript, TypeScript. I think it has been pretty obvious to anyone who even try to learn. There are the different learning curves, and after that, some language might have more surprises to you. Kind of, you might thought it works this way, but it turns out to be completely different, right? So that's kind of how people generally say, oh, this language is either easier or harder to learn. And the other perspective is when you actually try to use it in production, would all those kind of unpleasant surprises cause big problems, right? I think the later part becomes even more severe, or kind of could have disastrous consequence in smart contract world. Right? So especially in, when people talk about Solidity, especially in the early days, there's a common pattern like a re-entrance, right? When you as a programmer write a function or write a function call in the smart contract, you have some kind of call flow in your mind. But when it actually got deployed in the network, sometimes it happened differently. And that's kind of, in the beginning, many of the issues, all kind of hackers, it's kind of debatable, right? They just call a function. They kind of, I saw this as a, a call flow that's allowed by the language, by the EVM system, and they just did that, right? And then, millions or even billions were stolen. Later on, especially like Move, starting from the beginning, try to kind of solve this problem in a more fundamental way. Say, let's just do not try to keep everyone's money as a simple number. Let's kind of introduce this resource concept, and all the things followed. Right? I would say that's definitely beginner friendlier. In other words, even if you're someone kind of new to this programming or even new to smart contract, it's less likely you write a contract that makes, that has a vulnerability that could lose billions of dollars. I think that's kind of my, the major takeaway from the high level. Try to find a balance between, again, I'm still trying to gauge how technical or how, general I should touch on the topics. Yeah.
Awesome. Yeah, that definitely great to be able to navigate these levels. Just really quickly, also want to welcome Edgar from the marginfi team, building on Solana. Would love to get your point of view on Rust as well. Get that well represented. So yeah, maybe you want to do a quick intro as well before we continue.
Hey guys, how's it going? Sorry, I ended up in a place that was way louder than I expected. Thanks again for having me. My name's Edgar. I'm the founder of a borrower lend protocol on Solana called marginfi. Background across tech and finance. Started way back when in traditional finance. Moved over into tech. Most of my time on the data side of the stack. So in a lot of ways, DeFi for me is kind of 2.0 of a lot of industry problems. Really exciting to kind of see how they've reemerged, and definitely the conversation between programming languages and development frameworks when it comes to smart contracts, I think really important. Talks about kind of enabling developers and then the different trade-offs that these languages make. So yeah, definitely looking forward to being here.
Awesome, cool, thank you. So maybe I can also give my own perspective of how I see these different languages, and maybe like the simplest way I can explain it is every language itself is useful for specific purposes, and at the end of the day, you're just trying to change zeros and ones on a computer. And for some of the languages that interact more closely with the machines or servers or nodes and infrastructure like blockchain, you might have certain features that make it safer, like the language being static, for example. And maybe some of the folks here that are a little bit more technical can go into what that means. But yeah, Rust is one of those languages that overall is becoming very popular as a low-level language that interacts with machines really, really closely. And Move is a framework on top of Rust, and it's built on top of Rust, so that you essentially are able to build smart contract languages with guide rails. And Solidity, to be honest, I'm not sure like kind of where it came from, but it looks like a TypeScript or JavaScript language in order to interact with, I guess, the Ethereum Virtual Machine and eventually all the Ethereum nodes. But yeah, that's kind of how I think about it. But yeah, would love to hear anybody else's kind of like, not technical or explain to me like I'm five explanation.
Probably I will try and have a go here because I'm also kind of mostly non-technical on this aspect. But also, we would like to talk about this because probably we are only one of the very few teams that has worked in Solidity as well as Rust as well as in Move as well across EVMs, Solana, and Aptos at this point of time. So at the end of the day, what we believe is what is the kind of use case that you are trying to solve as such. What kind of developer are you? What are you looking to solve? What are you, because I believe each of these three languages have its specific use cases as such. So, if, for example, if you are going to go have to develop on EVMs, I don't believe you have much of a choice except going in for Solidity, which has its own advantages, being one of the earliest languages used for smart contracts. And it has been developed specifically for smart contracts. I believe that you cannot directly compare, say, Solidity with Rust as such, because Rust is more kind of a generic language. It wasn't developed for smart contracts. It wasn't developed for blockchain. It was developed for a much wider audience as such. Rust as such was developed for a much wider audience, which means that it is likely to handle security, mainly because security much better than any of the other blockchain languages, mainly because it is a much more low level language as compared to say Move or Solidity as such. And so again, it depends on what your usage is. So if you want to just get into blockchains, just to try out some core blockchain programming, again, in terms of ease of use and ease of learning, I think Solidity is still the best bet across the languages as such. And Move, on the other hand, is an upcoming language. We personally like developing on Move. I think it is best of both worlds in the sense that it is not as complex to develop as Rust, but at the same time, it is not as easy as Solidity as well. And for example, in terms of security, again, it is somewhere between Move and Solidity. Sorry, somewhere between Rust and Solidity as well. So Move has its own advantages as well. So at the end of the day, it is all about what we are looking to solve and what is the use case that we are trying to implement as such.
Sorry, I was stuck on mute. Jazzy, I think you were also gonna contribute here. Some thoughts.
No, yeah. I was just gonna talk about like where I think Solidity came from. So like Solidity is Solidity is the oldest language, right? And I think their main purpose, like as you said, is to like get the JavaScript, like it's basically JavaScript, but on the blockchain. And as you know, JavaScript wasn't really designed with a lot of internal consistencies in mind. And Solidity originally, I think the main purpose was to onboard all the web developers to the blockchain, especially when EVM, like in the early days of EVM. So that's what inspired a lot of original Solidity design. And I think both Solidity and Move like blockchain specific languages, whereas Rust is like again a language that's used like not specifically for blockchains. And but like I don't think much more to add there.
Awesome. Cool. Yeah, I think one interesting aspect of Move is that it came after obviously Solidity and Rust. So seems that second mover advantage there. They were able to learn from a lot of the missteps or maybe some of the drawbacks of Solidity to improve upon it. So exciting to have this entirely new language. We have another speaker here, co-founder and CEO of OkayRelay and advisor to Sokio. We'd love to come up and have you introduce yourself a little bit and for the audience, and we'll continue on.
Hey, awesome. Thank you so much for having me, and I apologize for being late. I was actually heading back from the main event back to my hotel to make sure that I have a quiet place to participate to the call. So really apologies for being late. So my name is Fode Job. I'm a founder of OkayRelay. We are a serverless solution for cross-chain message passing or message relaying. I am previously at Wormhole protocol. And now we are basically just working on a solution to help create an environment for cross-chain relaying as a service, as a matter of fact. So right now we support about 24 chains, all the ones that Wormhole support. And currently our platform can help like send messages between EVM to Move-based chains like Sui, like at the moment, or Aptos basically. So we support Move, we support Solidity, we support Rust, and we also support a little bit of Anchor for Solana. And that's what we do currently. And from my on my other gigs, basically, I also help Zokyo on the smart contract auditing side, and I also advise on Toshi Fund on the new projects we will be funding in the future. So that's basically a short about me.
Awesome, cool. Thank you. So I think this is also a good transition to talk about some of the some of the trade-offs that exist between these languages. So we definitely hear that Rust and Move are safer than Solidity, but what does that even mean? What does safe mean in a blockchain setting? So yeah, we'll throw that over to some of the auditors that we have here as speakers, maybe to kick it off.
Oh yeah, I mean, so I can take it off. So like, we have worked with like both like EVM, like Move and Solana, and like if I were to rank the languages like based on how I think like how hard it is to shoot yourself in the foot, I think Move makes it really hard to shoot yourself in the foot, especially with its like linear type system and the resource system. It basically eliminates a certain like classes of bugs, such as, for example, like duplicating values or like duplicating coins, which I think really is the way to go forward. Along with that, since like Move was specifically designed for the blockchains, it has a formal verification support built in, where because of linear type system, it is like relatively easier compared to both EVM or Solana to formally verify the logic on chain, because that was a first party use case. EVM, like I don't think EVM wasn't like, I mean, like back when EVM design, like there were like no best practices on like how and what people will eventually end up developing on the blockchains. So I can see like there weren't a lot of design considerations taken into account on, like, for example, like reentrancy and value stuff around that. Rust, on the other hand, I think, so Rust really shines in, for example, on Solana side, like in the case of error handling, or like, I would say like Rust is like much better than EVM in terms of like making it hard to shoot yourself in the foot. I mean, apart from a bunch of like Solana specific design decisions, for example, like when Solana was in its early days, all of the accounts were not verified, and like there were some Solana specific issues, but like so far, like especially with the anchor, a lot of them have gone away. So I think that's good. But happy to hear more perspectives.
I personally think that basically Move just benefits from all the security features of Rust, because Move itself is pretty much a Rust dialect, and it was implemented in Rust itself. So I believe actually that it basically benefits from all the security attributes of the Rust programming language itself. And if you look at it like overall, like these past few years, with all the surveys that came with Stack Overflow and such, regarding just developers loving Rust itself, like as a language itself. And I believe actually this Move benefits from that, because ultimately, if you are a Rust developer and you understand exactly how memory features work, how the borrow checker works, how all the basically low level memory management constructs work in Rust itself, it's easier for you to pretty much reason about writing smart contracts in the Move language itself, right? So I think because again, Denham just actually mentioned earlier, before, with the resource based language, the Move prover and the Move verifier built in the language itself, I think it sets definitely Move apart from language like Solidity overall, actually, just for designing smart contracts from the gate. And I think actually that's how Move benefits from. That's how Move basically differentiates itself from other smart contract programming languages.
Awesome. Yeah. We'd love to also hear some perspectives from some of the folks that have built, some of the engineers that have built with Solidity, Rust, and Move, or even just Solidity and Rust, given that their Rust and Move are so similar. Kind of curious to hear your perspectives, maybe Like, do you feel like you can sleep at night a little bit better with Rust-based languages than Solidity?
Yeah, I like to pitch in here. So I think basically the consensus here is that I mean the consensus among the engineering community is that Move is definitely the safest language among all of them. I mean, obviously there's the benefit of hindsight, being able to learn from all the mistakes that were made with Solidity and with some of the probably Rust based platforms. So I think this has already been mentioned that Move language makes it impossible to have reentrancy bugs, which affected a lot of the early Solidity based protocols. And then probably the other thing that's worth mentioning as well is that because of the way that the Move languages supports linear typing and resource management, um, it becomes a lot easier for contracts to just compose in a way that is fully permissionless. I'm not sure how often this comes up, but basically, when one protocol is trying to compose with a contract from another protocol, be it on EVM, on Solana or something, there usually is a significant amount of trust involved. You need to be able to trust. For example, let's say I'm protocol A, and then I'm going to write my contract in a way that it talks to you, and then depends on protocol B's contract. Then basically, I need a way to make sure that okay, maybe protocol B is not going to rug, is not going to do anything malicious in their contract, such that it damage. By composing with them, that interaction is going to damage my users. So there's some level of trust that is needed. The way that Move handles resource management has introduced I think some fairly dramatic change to that trust-based model of composition, in the sense that it's a lot easier now to compose contracts with zero trust, because basically, when in the Move language, let's say I'm protocol A, and then I compose with contract B, from another protocol. All I do is that I pass a resource from my contract to the target contract, and then the target contract, all that it is capable of is manipulating that resource that I have passed to it, and it is literally capable of doing nothing else that's going to impact my user. So as a result of this approach towards resource management, it basically becomes possible for protocol composition to become fully permissionless. And I think that's something that's probably not possible in Solidity and in Rust, and that's part of the reason that protocols and contracts written in Move is a lot safer.
Nice. Yeah. That's definitely super interesting. Kind of curious to hear what some of the use cases that come out of that composability. Maybe yeah, if you want to chime in on that, or handing it off to someone else to carry on. Yeah, I guess just a recap question.
Yeah.
What are some of the use cases that come out of that specifically?
Yeah, sure. So at Hippo we are building a DEX aggregator, and we're going to build a lending aggregator, yield aggregator as well. So basically, we compose with a lot of contracts, and if we were a DEX aggregator on, let's say, Solana or on EVM, we would probably ask the DEX that we compose with to show us an audit report, and show that okay, their contract is non-upgradable, and that probably there's nothing malicious in their existing contract. We need an auditor to go through their code and tell us a conclusion, so that we can trust, okay, it's safe to compose with this DEX and that DEX. Whereas on Aptos, when we're building Aptos using Move, we never ask our DEX partners for audit report. We simply don't care, because our contract is written, because the Move language basically enables us to write our contract in such a way that it's impossible for our users to be affected, even if the underlying DEX that we connect with contain malicious code. So basically, anyone who wants can basically get connected into the Hippo aggregator, and we don't ask for audit reports. We don't ask for that kind of traditional trust-based gatekeeping. We are much closer to the to the ideal version of Web3, where things are supposed to work permissionlessly.
Yeah, that's great. Being able to connect all these things and with a level, at least with a level of certainty that there's not going to be any issues to the existing contracts is huge. Yeah, kind of curious to hear. I guess. So okay, establishing that Move is relatively safer than Rust and Solidity. How can we think about the adoption? Kind of curious to hear. How difficult is it for a Solidity or Rust developer to start using Move? Yeah, Junda, maybe would love to hear your perspective here.
Yeah, I think that. No, before that, first I want to echo discuss earlier statement. I'm not 100% convinced. It's a programming languages, right? It's like how do you compare? It's like a tool, a knife. You can still cut yourself or hurt somebody unintentionally if you're not careful. Like there are like a language level guardrails that try to prevent you to do something, but in the end it's still up to the developer, right? The developer can still do stupid things or silly things that cause the damage. Since we talk about Rust security, I kind of, because we work in the cross-chain space, I remember about a year ago there was a big I think it's a wormhole hack on Solana. It has something to do with either a function call or API that kind of got exposed a vulnerability or something. I think at that time that was kind of a pretty big number, about more than 200 million or something. So I think the language level can give you some, you could say, helpers, right, to reduce the possibility. But in the end, it's still up to the developers to be careful. And from our own experience, we started, and because of course, right now, the EVM chains are the majority of the market. So we started as the EVM only. We interconnect with, I think now it's more than 40 chains right now. So majority of them were EVM chains in the beginning. So we had the whole suite of smart contracts, not just the basic functionality wise. So you can safely, transfer or burn or mint whatever the tokens across different chains and make sure there is no issue. There are also kind of additional layer of, self-monitoring. Like for example, if you suddenly see a super large amount token transfer out, right? Naturally, you want to introduce some kind of delay transfer or kind of some holder period to give the to give the team some time to kind of make sure, it is kind of a normal behavior because there was another chain has the money, the same amount or similar amount of the token asset or deposit. And also the other part is, we added all this kind of trigger alert system to monitor for our off-chain system to monitor, what is actually going on? Is there any kind of mismatch, right? All these smart contracts is tedious or not easy to implement in Solidity, but then when we want to connect to Aptos, the reaction from the team has been, once you kind of move on, bypass the beginner, like the beginner tutorial, the actual writing of the code or re-implementing the similar logic in Move is actually much easier compared to Solidity, right? That's kind of the welcome feature we kind of feel really beneficial to us, especially when we want to extend to more blockchains, right? And to give a concrete example, we have to use the Ethereum KCAC hash internally and everywhere for bunch of verification and also the data integrity check. Initially, it wasn't in the Move language, and we contact the Aptos team, say, hey, just tell us your roadmap, right? Your plan, right? If you say it can be done in a week or month, we will just wait for this feature. Otherwise, we are happy to move on to kind of develop a separate system using different hash just for the Aptos chain. Of course, we are very happy this feature gets implemented in like within a week, and then we can try to match our Move contract in terms of the functionality, in terms of the logic, as much as possible to the Solidity, because the Solidity code has been kind of well audited. It's much easier for us to kind of almost like a contract to contract, not copy or clone, but kind of in terms of the logic and decompose part, make sure all the features are there, and we are more confident to say, okay, since our Solidity system, EVM system, has been running for like almost 2 years now, the same logic given Move has much less things to worry about. We are more confident to kind of deploy on the Aptos mainnet. So basically, the overall development time from we start the project and explore the different choices to actual mainnet launch, production launch, I think it's about 1.5 months. It's kind of considering it's kind of a whole new different system, including our own internal backend and monitoring system. It's a pretty short time.
Yeah, that's really great to hear that the migration process or the refactoring process, I guess, into Move from Solidity is relatively painless, and actually that you as a developer really enjoyed more, after that initial learning curve, which doesn't seem to be a lot. Obviously, if you're a proficient developer, learning new languages is part of the job. So that's really great to hear, and I think really bullish for the Move ecosystem, that as more people pick it up and it's relatively safer. That we'll be able to get better security and better, maybe even more developers coming into the space, given that there's a safer option. Kind of curious to hear again from a non-technical perspective a little bit, whether Solidity or the Ethereum space, whether they've done any improvements, or how some of these issues like reentrancy errors or maybe like resource management is handled on the EVM or on Solidity. Just kind of curious to hear like what are some of the workarounds, or how are some of these issues that Move handles dealt with on Ethereum, or sorry, the EVM. Maybe pass it over to Foji.
Oh yes, okay. Well, just by default, actually, that's really what attracted me to Move initially. I think one gentleman mentioned it earlier, the way that Move is more like handles resources within the language itself. Because if you look at Solidity itself, right, actually the assets live inside the smart contract itself, right? Because overall, a Solidity smart contract is pretty much a mapping between an address and some kind of value, right? With Move itself, like all that basically hassle is taken away from the smart contract itself. And I think someone mentioned it earlier again, where when you basically build in composable smart contracts in Move, or if you want to basically pass assets or resources to like a DEX and do it in a trustless manner, this is actually the best way to do so, because even if there's some kind of a like bug or some kind of malicious intent on the other side, you are not worried that basically that your users will lose their resources. And I think to me, that is the prime basically selling point for the Move programming language itself, right? That the resources actually do not live inside the smart contract. So when it comes to like certain bugs themselves, where the user's assets will be at risk, all that worry is pretty much taken away with the Move programming language, which again, to answer to your question earlier, allows us for developers to basically sleep better at night.
And to just add on to that, again, it is a question of how the language is structured. as someone mentioned earlier. When Solidity was built, it was built for specific use cases at that point of time. Because since it was the first blockchain, core blockchain programming language, it did not envision at that point of time that what would all be the use cases for it and how it was going to be used in the future as well. Move has the advantage of hindsight as such, wherein it has already seen what are the problems, what are the types of use cases that are that for which the Move language is going to be used for and things like that. So, especially when we talk about reincurrency attacks as such, Solidity wasn't designed for that. Structure of the language is not designed to handle this, but it has evolved. To give credit to the Solidity language as such, it has evolved over the years. Right now, it has libraries that handle these kinds of attacks. But on the other, but at the end of the day, it all depends on the user at the end of the day. Because Solidity by itself is a dynamically typed language, which means that unless you are careful, unless you use the correct libraries and correct form of code, you are likely to fall into different traps as a developer. Whereas on the other hand, Move is a statically typed language, which means that it is more robust in terms of re-entry attacks and things like that, and security and things like that. The structure of the language itself is more helps it to handle security in a much easier and better language because of the guardrails around it. So yes, so at this point of time, Move, in terms of security, Move seems to be the better option. And one more thing to consider, in our opinion, is that Move is a much more powerful language. I believe currently there are different frameworks of Move, there are different versions of Move that are being used by different networks at this point of time, and the Move has a capacity to expand itself. What we are seeing in Aptos right now, I believe it has the version of Move that we are seeing in Aptos has the capacity to expand even more. It is a very powerful language. I believe that all the use cases, or the entire possibilities of what can be achieved with Move cannot be currently seen in Aptos. It is evolving at this point of time. And once it is fully evolved, it is likely to be much more powerful than what we are seeing right now. Yeah.
Yeah, the ability to evolve the code bases for this is actually super interesting. Yeah, kind of curious to hear your perspectives on that ability for Move versus Solidity, or yes, maybe some other languages. I think Junla, you also mentioned this. But yeah, kind of throwing that out there. What do you guys think about the ability of these languages to continue to be improved on? It looks like the Move repo is being yeah, contributed to almost every day. And maybe also, what do you think is missing?
Yeah, I want to add, it's kind of a delicate balance between a stable feature versus kind of, say you implemented all the logic you need and it runs on the blockchain. You don't want to come back every month or every 2 months because of some underlying API update. You have to change your code, right? That will be kind of the believe it or not, it actually happens with some blockchain, right? So that actually we had experience with. On the other side, the kind of back to your earlier question about this, like, how about Solidity? Like, how much change? If you look at the Solidity, again, Solidity is just an abstraction for the underlying EVM OP code, right? So basically, there is a virtual machine runs different, instructions, and Solidity just kind of try to give it a layer of abstraction, a wrapper for the human to kind of interact with the virtual machine, more easily. If you see, go check some of the more serious production project Solidity repo, you will see assembly code in there, here and there. That kind of tells you the maturity level of the language is not that high, right? But to be fair, right, for any serious project, they would not only use Solidity like barehanded, like start from scratch everything. They have this Open Zeppelin as a pretty, high quality, battle tested production level. You could say libraries or like ready to use building blocks, like for example the reentrance attack, right? It's a modifier you can just add to your function. In the end, it's from reading the contract, just add in the end of the function name, there's a suffix or something like that. Try to find the balance between technical and non-technical, and that basically tells the EVM, hey, do not re-enter this function when you execute, right? So I think that kind of is the layer of where they do the innovation or where they draw the line, right? So the language or the Solidity could just say, hey, we are just this layer, of course, far from perfect, far from, even not that much easier to use or safe. But then there are teams that come in and build relatively high quality, reusable libraries and building blocks. So if you are a project that focuses on specific use case like cross-chain messaging, whatever, DEX aggregation or something, you come in, you do not write the Solidity line by line, right? You start from some of the ready-to-use components, especially from Open Zeppelin. I think that's kind of their, decision of the entire ecosystem, especially with developers. For Move, I say, it's kind of very, the layer one, like Aptos chains, they have strong engineering team and they dedicate from the consensus layer up to the programming language, even to the IDE or the helper tools, or even formal verification. So kind of the entire tool chain, right? So that kind of is, I would say, relatively easier to kind of jump in and start to build something that's ready to ship, right? So compared to the Solidity or EVM world, you still need to know where to find the right pieces, or kind of even for Open Zeppelin, right? They have different implementation. You still need to figure out the internal details. Should I use this one or versus the other one, right? I think for the Move ecosystem, it's kind of the experience is relatively hassle free, right? So you have much less frustration. So why doesn't this work, right? What does this error even mean? So that's definitely give the developer a much better, onboarding experience. But in terms of the next level, say they become more serious, and the projects will handle more volume, more transaction. They want to beef up every aspect of it. Then they can say, oh, because the most critical part of the security is already handled in the system level or language level. So we just add some kind of surrounding auxiliary contract to help monitor or something. I think that's from our like 2-year experience working with different blockchain, different smart contract languages. I think I kind of view that as a very powerful how do you say a powerful feature to attract new developers on board.
Nice. Any other thoughts from others as before I move into change the topic a little bit? Cool. So yeah, we've talked a lot about the safety and ease of use of Move over Solidity and Rust. Kind of curious to hear some of the performance improvements. So and I guess some of this might be inherited from Rust, but yeah, what are some of the differences in making I guess higher performing implementation? So for example, Move, as I know, is used currently only for Aptos and Sui, but are there any benefits in terms of performance as well on top of the security and ease of use that we discussed? And maybe also, how do we even think about performance in this way?
I guess in this case, it's important to distinguish between language performance and virtual machine performance. So in theory, it's still possible to compile Solidity or Rust or Move down to some sort of, let's say, more native representation. The technical people know it as assembly code or LLVM It's still possible to compile these high-level languages to something that's a lot more low-level, and that can be executed with like perfect efficiency. But the reality is that these specific languages are usually bound to a very specific set of virtual machines. For example, Solidity is bound to EVM, and then the Move language is usually bound to the Move interpreter. Rust in this case is probably way more free in the sense that so let's take Solana for example. So in Solana, Rust is compiled down to BPF, and then there's like very efficient execution engine for BPF representation. So in this way, you could say that Rust is actually more performant because its execution engine, at least on Solana, is really like close to the metal. Whereas EVM and Move both actually run on some sort of interpreter and are therefore like 100 times slower. Yeah, so I guess that's the high level overview here. So Rust, it's a lot easier to squeeze performance out of a Rust code, whereas because Solidity depends on EVM and Move depends to a large extent on the Move interpreter, so it's a lot harder to squeeze that kind of a close to metal performance from these languages.
Yeah, that makes sense. More so, I guess on the virtual machine. Kind of curious, maybe on something like WebAssembly, whether if you were to put two of these languages side by side, what that might look like.
Still, I would say that in theory, let's say just put that virtual machine part away. Let's say we compile and execute Solidity in WebAssembly, and then we do the same for Rust. We do the same for Move. I would say it's actually the three would actually perform on a very similar level. It's just the reality is that probably it's highly unlikely that someone is going to compile write Solidity and then have it compiled to WebAssembly. And there are teams that are doing that. There are L1s that are doing that, but it's probably not very popular. And then probably same goes for the Move language here. Since right now it's mostly maintained by Aptos and Sui, and both projects are 100% dependent on the Move interpreter. So in theory, it's still possible for another team to write another backend for the Move language and have it execute on top of WebAssembly. That's definitely possible. And if they do that, they're probably going to get a very significant performance boost. Yeah, it's probably a matter of marketing whether such a team is going to succeed or not.
Yeah, that definitely makes sense. Any other thoughts here on performance from other folks?
Yeah, it is pretty much what Mana said as well. So purely from a language point of view, I personally believe that Rust is likely to be the faster one out there because it's a much more low-level language when compared to Solidity or Move. So purely from a language point of view, it is likely to be the faster language in terms of execution. But obviously, it also depends on the underlying chain that is there. So if you're going to execute it on Solidity as such, execute it on EVMs, it is likely to be much slower than when you execute it on the other blockchains as such. So yes, so in summary, purely from a language point of view, personally, I believe Rust is likely to be the faster one after before Move and then Solidity as such. But again, from a Yeah, from a underlying chain point of view, underlying virtual machine point of view, Solidity is the one likely to be slower because it is used on events as such.
Yeah, that makes sense. Any other thoughts from anyone else?
Probably the only other thing that's worth mentioning when it comes to performance is that the performance, we don't talk about, it's rare for us to talk about the performance of a language in isolation. Instead, what we need to talk about is also, let's say, the performance of consensus, because sometimes the L1 is not limited by the language or by the virtual machine, rather it's limited by the speed of consensus, the bandwidth of the network, how reliable the network is. So yeah, a lot of the time, probably it's not the language alone that determines how performant an L1 is. There are like a lot of other factors that need to be taken into consideration as well.
Yeah, I'm not sure where I read it, but I just for some reason in my head I remember reading that Move and Rust were optimized for parallel transaction execution. So I don't know if that's like a wrong statement, but yeah, or if someone wants to comment on that.
Yes, they are
Yeah,
multi-thread actually. They are sorry.
I kind of agree with the half of it, right? So basically, there is kind of the, again, right, all the performance argument comes down to the state update. Like for example, in Solana, for parallel execution, they basically they basically put this as a burden on the developer. So basically you have to maintain your own, basically inside your code, you have to deal with different storage slots. So, try to randomize this. So naturally, it can support more concurrent updates because the underlying storage slots are different, right? So, but that slots are visible. Basically, it's not transparent to the developer. The developer actually have to like carefully, intentionally manage them themselves inside the code. So that's the burden. The parallel execution on the parallel state updates are always possible. It's just how you put the right layer of abstraction, right? So one way is, of course, you say, okay, underlying, I'm sharding 10,000 pieces, so I expose 10,000, slots to the developer. The developer's responsibility to handle everything by themselves. And of course, if the developer is not careful or lazy, it doesn't get benefit from your underlying kind of parallel state updates, right? And for Move, they kind of put that layer in the middle again, right? So I try to avoid talking about to involve Rust because again, right? Rust in general, I think it's a generic programming language. We could talk about some specific blockchains and how their choices or their flavor of Rust and design or their APIs, right, kind of affect the thing. But a more direct comparison is to Move directly. The Move team basically say, okay, we do all this. How do you say the story? If you're familiar with the resource everyone has been talking about, the resource ID has an internal kind of randomization, right? But from the programmer's side, you deal with the reference or the resource objects IDs. That's kind of more how do you put it, familiar, right? Instead of you say, okay, now for everything I need to save, I need to figure out where do I save it in some other blockchain, right? I think that's kind of the power, a right layer of abstraction, right? So fundamentally, any claim to be high performance blockchains can support and must support parallel state updates, right? Otherwise, of course, there is no performance argument. Right? But for any parallel updates, there's no magic, right? So basically, the distributed system has to work in a certain way to reach consensus. So naturally, you shard your state, the global states, and then the question is just how much of your internal sharding implementation or details are get exposed to the developer, how much layer or effort you put in the middle to help the developers kind of can benefit from the underlying mechanism, even though they don't even need to think about it. So I think that's the key part of the difference. The Move team in general, including different Move chains, inherit from the original Move, the Libra code base. They kind of keep improving on this layer of abstraction. So we do not need to worry too much about, would it ever run into a performance issue?
Yeah, that definitely makes sense. I definitely have heard that it could be very difficult or perhaps easy to deal with or deal in a wrong way with the resources or the storage on Solana. That's like a difficult aspect of coding there, and seems like Move definitely makes that a little bit easier. Kind of curious whether how Solidity handles this. Is it how it handles I guess storage, and whether it's even possible to do this type of parallel transaction execution with Solidity.
So there's actually a team, Monad, if you guys have heard. They are trying to do exactly what you just mentioned. So there is not like a design restriction on EVM that you can't do parallel execution, but it's just designed in a way that it's just like single threaded. But if we were to assume that there is two smart contract calls and they both touch different storage slots, there's no reason you can't execute them parallelly. And I think there's a couple of teams working on that. So yeah, I think it's definitely possible, but it would be hard because you have to rip apart all of the EVM and rewrite it. But I think it's doable.
Yeah, that makes sense. Super interesting. We'll have to look into it. So I know we're running on time, so I want to hit some of these questions that I think are super important. So is there any feature that you feel is painfully lacking in Move that Rust and Solidity have? So maybe Forge, we'll kick it over to you.
Sorry, can you repeat the question again? You said any features of Move?
Yeah. So is there anything that Move is missing that Rust and Solidity have?
That's a good question. I'm assuming probably like tooling, because Solidity has been around for actually quite a while now, and Rust as well. And since like Move is still such a new language, I think like maybe like better tooling, obviously for the future, will work for Move. But that's all I can see right now. Just tooling.
Yeah, that makes sense. Given it's a new ecosystem, a lot of that legwork has to be put in. Man.
Exactly. If I could add something as well, it's like, well, a lot of stuff I'm moving is actually missing right now. But and I want to actually bring this up because I haven't actually heard it yet. Just the elephant in the room, which is like large language models like ChatGPT. Because I'm actually curious to know also, like in the room, if anybody's like, what have been your experience using writing smart contracts in Move using ChatGPT? Because personally myself, I use it more and more every day now, and I feel like maybe in the future we might not be actually writing as much like smart contracts like as developers, but maybe actually we'll spend more of our time reading and auditing actually code that ChatGPT wrote. Because right now I write my unit tests in ChatGPT. I put in code that I see from the SUI Foundation Mission Labs to explain to me what the code does, and I use it actually more and more these days to basically optimize my code as well. So I'm wondering actually if in the room people are using it actually nowadays, and how is it making your experience better?
Yeah, no, I can add a bit more. So like specifically on like if we compare it to Rust, Rust has a very strong type system, and there's a lot of abstractions that can be built on it. For example, my friend here, Donut, he wrote this abstraction framework called Daiquiri, which allows you to do essentially authorization based on the type system. And I think there's just a lot of things that can be built on Move that are like basically that can build while leveraging the type system that it's still lacking.
And this is again from a purely non-technical point of view. Move is a developing ecosystem. So what happens is that at this point of time, the entire Move ecosystem is heavily dependent on the Aptos and the SUI developers to grow the space and to help evolve, Move evolve into the different use cases as such. Whereas on the other hand, we have to, I believe the Move ecosystem has to learn from the Solidity ecosystem. If you notice over there, a lot of the use cases, a lot of error handling, a lot of libraries have been open sourced and built by the developer community as such. So they weren't just dependent on the Ethereum core team or the Ethereum development team for Solidity to evolve. Much of the evolution of Solidity was mainly through the developer ecosystem that came along with it. The open sourcing, the sense of community, the development developer community, and things like that was the ones which contributed around 60 to 70% of the evolution of Solidity. I believe Move has to learn from that. Actually, the Move ecosystem has to learn from that. It has to be more open source. It has to be more. It has to have a bigger sense of community, so that not all the work can be done by the Aptos or the SUI developers as such. It has to be a much bigger ecosystem that contributes to the evolution of Move as such.
Along those lines, shout out to Mana for contributing a lot. The TS SDK is definitely huge. But yeah, anyone else thoughts on this, and also to throw back out the question on using ChatGPT for coding. I thought that was super interesting. So yeah, if anybody has thoughts on that too. Maybe pass it to you, Mana. Yeah.
Yeah, just a random thought about this ChatGPT thing. I think we've all seen some demo about using ChatGPT to reverse engineer, to basically convert from assembly code to high level human readable language. As far as probably one possible use case is that we could probably use it to basically decompile some of the contracts that have been deployed on Aptos or SUI that are not open sourced yet. I guess that could be some fun task for someone else to try out.
Yeah, that's a super interesting use case. Great. So as we coming up on time, yeah, would love to hear any parting thoughts or any last thoughts that you'll have. So yeah, I'll just open it up to the room.
Okay, I'll just go here. So I just wanted to add to what I was saying again about ChatGPT. Personally, internally, right now we use it pretty much for pre audits, right? Because I believe that actually the ChatGPT can really help you save money for your auditing your Move code. It doesn't really get everything all the time, but it can find some low-level bugs which actually, can save you time and money in the future. And I think actually, like as these language models actually grow and get better over time, the pre-audits will get better, and I'm sure it will be able to catch again. Actually, even like more like low-hanging fruits like gas optimization bugs or and whatnot. So I think like ultimately we want to be able to actually grow the Move ecosystem, and I think as we basically feed Move code to ChatGPT, it will get better and stronger and actually help us actually write more secure code. And I think maybe it should be definitely incorporated more into crafting smart contracts in Move for sure.
Yeah, hopefully we all still have jobs in 10 years.
Yes. Yes.
No, why don't you say hopefully you will retire in 5 years?
That's also true. Yeah. Yeah. Any other parting thoughts?
Yeah, in the in the Ethereum ecosystem overall, there's recently the zero knowledge related stuff pretty popular. In their next is it Shanghai or some other update, they will add more, official precompiled Solidity support for zero-knowledge proof verification. Those things, again, right, because like Aptos and all the other new high-performance blockchain, they don't have this, need for layer 2 or whatever. That kind of might be a slower change that gets supported. But for us, say there will be a zero-knowledge based bridge. It actually definitely depends on some like a precompile. Otherwise, if you do everything in the smart contract code, that would be too expensive, right? So I think that could be one of the things the Move, language-wise can support. The other part is the fork issue. It's like there was this original Move, and then there are different flavors now. Initially, we thought, there are different blockchains all support Move, so we just write once, like EVM. But turns out different blockchains have their own, design decision that actually make the change incompatible. So we actually have to, yes, it's definitely easier than start from scratch, but it's still more work compared to like I write one Solidity once and gets deployed on almost all EVM chains. Right? So I think that's down the road. It just like if you're in the computer science, yeah, it's the statement that shows the age. In the old days, even C, right, as a programming language wasn't standard. Different compiler companies, have their own secret source or tricks and different behaviors. And then there was kind of more this standardization effort, so people don't worry about that anymore. Right? So I think that could also happen, or I would say would be better, needed, especially for developer experience side, because developers are always lazy. Everyone dream of write once and run everywhere, and for Move, right now, it's not a reality. So I think hopefully it can become a reality soon.
Yeah, definitely. That's a whole another rabbit hole to get down into. The differences between the Aptos and Move. Sorry, the Aptos and Sui differences in Move. But yeah, we'll leave that for another day, for another session. Mana, Jazzy, Karthik, any final thoughts?
No final thoughts. I think it was a great panel. Thank you for having me. It's great talking to you about Move and Rest and Solidity.
Yes, thank you for having us as well. So, yeah, as I have what said right at the intro as such, it is more about the rather than considering the different languages as something for competition. It is more of what use case we are looking to solve on this chain. I think each has its own advantages as well over the others, and they are also specifically stuck onto specific blockchain networks at this point of time. As Junda rightly pointed out, even within Move, we don't have a specific standard which makes it work across, which makes a single smart contract work across all Move virtual machines as such. So that is something that Move, which is an evolving and a new ecosystem, is needs to handle in the near future as such.
Yeah, I could definitely see someone building another layer on top of these Move languages, such that you just need to write your contract once in that layer, and it automatically compiles to Aptos Move and Sui Move, and so basically realizes your dream of run once and run everywhere again. But that's probably for someone else to take up the challenge again.
Yeah, definitely. If you haven't looked at Roosh, they were on earlier. They're building something. I think they're calling it the Move OS that does something very similar to what we just mentioned. So definitely check them out. But yeah, thank you everyone for joining. Thank you to all the speakers. Thank you everyone that was with us the whole day, and those that joined throughout the day. Excited to continue this conference. And again, if you're in Ethereum, Denver, if you're in Denver, come out tomorrow at 11 a.m. We'll be having some sessions live. We'll still be streaming on the Twitter. Going to try to figure out how to do it in a way that the audio isn't terrible, but we'll give it a shot. And yeah, thank you all for joining and being part of this historic moment.
Thank you for having us.
Thank you. Have
Thanks.
a good
Thanks,
Friday evening.
everyone.
Bye-bye.
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 Thank you, everyone. And with that, we'll wrap it up for the